so we're going to continue our discussion about ellipses. We have a couple more definitions to just make sure that we cover and that you've written down. Our major axis, again, is the longer or larger axis, and the minor axis is the smaller axis. So again, if something is called a vertical ellipse, the major axis will go vertically, as you see here in the picture. Now, from the vertices, they again are the endpoints of the larger axis, and co-vertices sound less important, so they're the endpoints for the smaller axis. The foci, if you need it, are the distance from center to a focus is considered a distance of c, and the relationship of how long c will be is connected to both the distance from center to vertex and center to co-vertex. And again, these were defined on the top of the notes for ellipses day 2 if you need them, or didn't take a picture in the previous video. As we go to talk about the actual example, I'm going to come to a blank graph and start it fresh with you. So when we are looking at our problem to find the center, vertices, co-vertices, and foci of the ellipse, the good news is the ellipse equations that we're going to look at today are going to be centered at the origin. So our center is h and k, and so we really want to look at how did it shift away from x, or how did it shift away from y. And when I look here, I don't see any shift. And so what that means is that my center is going to be at 0, 0. So I can start with a point there, I can list it and write it down. Okay. Now I want to think about the vertices. Now one of the things I remember about the vertices is that the vertices are going to be under the longer axis. So when I look at vertices and co-vertices, they are connected to these numbers that are in the denominator, so 9 and 1. And so I want to think about which of those is a larger value, okay? And in terms of that larger value, I have a value of 9. So if I know that a squared is going to be 9, then that would tell me that the a value is positive and negative 3. So what I want to do in terms of my graph is go back to the center and count that a value in a horizontal direction, because it's under the x, away from the center. So I count 3 to the right and 3 to the left, and those are my vertices. So I could use a little v for right now, but more importantly, I want to make sure that I list them. We'll list them as negative 3, 0 and as positive 3, 0. We don't need to write the word twice. All right, so then what we're going to do is we're going to recognize that the other value underneath, in this case the y, is going to be connected to my co-vertices. So we're going to say that b squared is 1, which allows b to be a movement of positive and negative 1 away from the center. And since it's underneath the y, I'll use that count of 1 in a vertical direction since it's under the y. So I'll list those co-vertices. Now when I list them, I want to make sure that anytime I have a 0 that I really pause and I make sure whether or not the value goes on the x-coordinate or the y. Okay, so since this is vertical, I moved 1 in each direction. So then what I want to do is I want to connect those points with a smooth, an extremely smooth looking curve. And so that curve is going to be called our ellipse. Now when I make that curve, I need to make sure that it hits all 4 of those points, the vertices, the co-vertices. But I want it to look as much as it can very smooth and, almost like an oval, so that it doesn't appear like a football or a quadrilateral, because that's not the shape and effect that we're looking for. Now the last thing that we're responsible for finding are the foci. So if you remember, you wrote down a definition here that connects that relationship. So c squared is a squared minus b squared. Now notice that's similar to our Pythagorean theorem, but it is not the same. So we want to make sure that we use the correct values. A squared is this entire value of 9. B squared is the entire value of 1. And so c squared itself will be 8, which means that c is plus or minus the square root of 8, which we can simplify to 2 root 2. So as you go to think about where those foci are, we can estimate that value. But more importantly, we need to recognize that that was a left and right movement. And the reason it's a left and right movement, again, is because this was a horizontal ellipse. So that movement of negative 2 root 2 to the left and positive 2 root 2 to the right affected our x-coordinate. Okay? And again, if you'd like to write down that this is a horizontal ellipse, that's never a bad idea because soon enough we will be needing to name that in our answers as well. And that's example 1.